Okay, let's go to example number 6. So forces F1 5.6 Newton here, and then F2 10.3 Newton are applied tangentially to a disc with radius 30 centimeter. And then the mass of the disc is 5 kilogram as shown in this figure here. So we have to calculate the net torque on the disc as well as the magnitude of angular acceleration influenced by the disk. So they gave us the moment of inertia for the disk, which is this one. So for question A, the net torque is basically just the addition of torque by force 1 and torque by force 2. Okay, and then we know that the formula for torque is force times dengan the perpendicular distance. Okay, and then in this case the perpendicular distance is basically just the radius of the disc lah. Okay, so radius of the disc is this one, and then yang ini perpendicular distance untuk force 1. Okay. So this is just R, and then R. Okay. So we then get F1 to be anti-clockwise, so this is gonna be positive F1 R minus dengan F2 R. Kenapa negatif? Sebab sekarang ni F2 is going clockwise. So if it's clockwise, the torque is gonna be negative lah. Okay, so F1 is good job. So I'm just gonna put R outside, so F1 minus F2, where R is 0.3, F1 is 5.6 minus 10.3. Terbalik. Kejap. Actually F1 yang the one clockwise. Okay, so if F1 is clockwise, then this is negative T1 plus dengan torque untuk force 2, which is going anti-clockwise, so this is gonna be positive, so T2, tau 2. And then this one is negative F1R plus F2R. Okay, so R outside, negative F1 plus F2. So this is 0.3 negative 5.6 plus 10.3. So the net torque on the disc is then 1.41 Newton meter. Okay, right. And then question B, we can apply the relationship between torque and angular acceleration, which is this formula, I alpha. Okay, so I is given, which is half mr square alpha, so this is 1.41. we've calculated that one. Then this is half times 5, which is the mass of the disc, times dengan the radius, which is 0.3 square, darab lagi dengan alpha, which is what we are looking for. So you then get the angular acceleration to be equal to 6.27 radian per second square. Okay, so that is the solution for example number 6.